Yeah, so I'm Hai-Ching Yang. I'm the current president of SAPA-GP and the co-chair of this conference. And then, yeah.
And I'm PJ Brooks. I'm the acting director of the Division of Rare Diseases Research Innovation at NCATS NIH.
Yeah, really, it has been a great pleasure to have you, at a conference and to be our plenary speaker. So I have a few questions for you. First, I'd like to hear from you. What do you like most of this conference so far, and what is your impression? What would you like to see more from this conference?
Well, it's certainly, first of all, it's an honor to have been chosen as the keynote speaker, and I very much appreciate that. I think there's a lot of excitement here, both in the city of Philadelphia and this conference specifically. There's a lot of people, I think, more than you had anticipated. Really nice mix of business and small business, big industry, academics. And of course, for me, the focus on gene therapy is very exciting and something that I really appreciate and something that we think a lot about.
Okay, thank you. It was very exciting to hear your talk about this beyond one disease at a time kind of approach. So, then would you pick up one technology breakthrough that you think may shape the next 5 years? What would you? How are you going to name it?
I would say, in terms of the next 5 years, probably base editing.
Base editing
as a type of genome editing. I think that as a therapeutic platform is one that I'm very excited about. And I think the timing is about right for the next 5 years. The prime editor that's been developed more recently, I think still is not quite into the clinic, but I think the base editor work is going fairly quickly. And the advantage of an editor that doesn't cause a double-strand break is important.
Yeah.
I think there's still delivery challenges on that, but that one in the next 5 years I'm quite excited about and interested to see.
Okay, and then what disease area you think may be more impacted by that?
I think there's a lot of interest now in ex vivo gene therapy for editing in hematopoietic stem cells. That's already moving. I think we're increasingly interested in vivo gene therapy.
Okay.
And the NIH Somatic Cell Genome Editing Program, as I mentioned, we funded almost 20 different awards on better delivery technologies, and several of those involve ways to deliver base editors. So I think often the limiting factor is delivery. So from that perspective, I think we're going to be seeing things first in the liver, the retina, and perhaps the CNS.
Okay. So in terms of, because CNS neuroscience area is dear to my heart, so what kind of delivery system you think may, for this, do you think it will be anything different from like AAV or, so what do you think?
Yeah, so I think AAV is obviously good for a lot of things. For the base editor, there's a bit of a limitation because it's too big to fit into the AAV genome. So it has to be split apart, but that works quite well using these INTENE tags that have been developed, and there's some really impressive proof of concept data using base editing, for example, in Hutchinson-Gilford progeria. That's, I think, very exciting. I think ultimately in the long term or longer term, non-viral approaches are very exciting because of the need for limiting the amount of time that these editors are present in cells. Once they've edited, they're nothing but trouble, so to speak. So I think one thing we're very interested in are non-viral technologies, and as I mentioned, we're particularly excited about the idea of, and they're even thinking about a prize competition to find ways to deliver genome editors, non-viral approaches to deliver genome editors across the blood-brain barrier and get into all the different cell types in the brain. And I think delivering them in the form of messenger RNA is really attractive, and this is, I guess, one of the few benefits of the pandemic, is the realization of the scalability of messenger RNA as a delivery technology in lipid nanoparticles.
Yeah, okay.
Because that's the base of the Moderna and Pfizer vaccines.
Exactly.
And so I
That's right.
think that's something that I'm very excited about. And the messenger RNA, you can avoid this. There's some flexibility in the size there, so you can incorporate a base editor.
Yeah. Okay. Thank you very much. Really appreciate it.